right, so let's go ahead and start with a handful of problems just to practice to make sure you remember what we've been doing. So we'll start first with a little multiplication of radicals. So I'll put the problem on the board. You guys take a minute to pause it, solve it, and then look up here for this worked out solution. So number one, we'll do 3 radical 40 times 3 radical 35. So remember, first we take the outsides, we multiply the outsides first. So 3 times 3, that's just going to give me 9. And then on the inside, I still got 40 and 35. This guy here would give me 2 times 20, 2 times 10, and 2 times 5. And over here, I get 5 times 7. So that's going to make 2 times 2 times 2 times 5 times 5 times 7. After that, since I'm looking for my perfect squares, circle everything that appears twice. So I get a 2, here I'll get a 5. So then on the outside, we still have the 9, and then we're going to get a 2 and a 5. On the inside, I'm still left with a 2 and a 7, which make 14. So when I multiply this stuff together, 9 times 2 is 18, 18 times 5 should give me 90. So I'm going to get 90 radical 14 as my final answer. Next one. If I have radical 12 times radical 20 times radical 24. Again, pause it for a second, try it on your own, and then I'll work the solution out for you. So you're doing this the same way as you are the other ones. Doesn't matter how many things are being multiplied together. The process is still the same. You still got to do outside times outside. In this case, there's nothing on the outside, so there's nothing to multiply. On the inside, you're just going to get all of these. 12 times 20 times 24. All right, so just take each number, start breaking them down. So this guy gives me 2 times 6, and then 2 times 3. This guy gives me 2 times 10, and then 2 times 5. Then I get 2 times 12, 2 times 6, 2 times 3. In total, you're going to have 1, 2, 3, 4, 5, 6, 7 2s. And then I'm going to get 1, 2 3s, and a 5. So if I'm looking for perfect squares, I have a perfect square here, perfect square here, perfect square here, perfect square here. So what's coming out is 1, 2, 3 2s, 1 3, and I'm left on the inside with 2 times 5, which makes 10. On the outside here, 2 times 2 times 2, that's 8. 8 times 3 is going to give me 24. So I'm going to get 24 radical 10. Try the next one. And 4x squared radical 18x times 2x radical 27x cubed. So again, we start by doing the outsides first. So that makes 8x cubed. On the inside, I'll have 18 times 27. And remember, combine your variables first. Makes it a little easier. X cubed, that makes x to the 4th. Take our variable out first. So this guy is going to come out as x to the 2nd. So that's going to give me 8x to the 5th when I combine this guy with this guy. And then I still have 18 and 27 on the inside. And now I got to break these guys down. So this makes 2 and 9, 3 and 3, 3 and 9, 3 and 3. So in total, I'm going to have just 1, 2, and then I'm going to have 5 3s. So I got a perfect square here, perfect square here. So I'm taking out 2 3s. So if I take out those 2 3s, and then I'm going to be left with 6 on the inside. So on the outside here, 3 times 3 is 9, 9 times 8 is going to give me 72. So I'm going to have 72 x to the 5th, and then I'm left with the 2 and the 3, which make 6. A little bit of division of radicals now. See what we remember here. So if I have, this is number 4 now. Radical 12 over 20. So remember, when we're doing these, you want to be simplifying each step of the way. Simplifying again means reducing anything that can be reduced. And then if they're perfect squares inside the radicals, yank those guys out. So first, let's reduce. If I reduce, this is going to give me radical 3 over radical 5. All right. Now I take a look at my radicals really quick to see if there's any perfect squares on the inside. Remember, when you're looking for numbers that have perfect squares, you're looking for numbers that can be divided by 4, 9, 16, 25, 36, 49, so on and so forth. These are the ones that are going to be the easiest. You should recognize really quick. If you see a number that can be divided by 4, it'll automatically go off in your head. Ah, there's a perfect square inside there. Take it out. If you see a number that can be divided by 9, so those are ones we should quickly recognize. There's a perfect square inside that number. In this case, there are no perfect squares. So now I'm going to multiply top and bottom by whatever the radical is. So I got to cancel this guy out here. So I multiply top and bottom by radical 5. When I do that, on the top, I'm going to get radical 15. When I do radical 5 times radical 5, remember, whenever we multiply a radical times itself, the answer is just the number that's inside the radical. So this just gives me 5. So the answer is radical 15 over 5. Remember, we can't simplify this. You can't simplify something that's inside the radical with something that's outside. That's the final answer there. Let's go to the next one. If I have square root of 9 over 8. All right, so you can't reduce on this one. We could break it up into 2 radicals, make it a little easier here. So let's break this up into radical 9 over radical 8. But even though I can't reduce, I can still simplify. I have perfect squares. As long as there's perfect squares, let's yank those guys out first. On top, square root of 9, that is a perfect square. So the top just becomes 3. On the bottom, 8 isn't a perfect square, but you do have a perfect square inside the 8. So let's take that out. So since this guy here would be 4 times 2, there's my perfect square, and that's going to come out as a 2. So I'm going to have a 2 on the outside and a 2 on the inside. So this can give me 2 radical 2. After that, now I have to multiply top and bottom by radical 2 because I can't leave a radical in the denominator. So times radical 2 times radical 2. 3 times radical 2 is just going to give me 3 radical 2. When I do radical 2 times radical 2, that just makes 2. Then times 2 makes 4. And then after that, there's nothing left to simplify. So this is my final answer. 3 radical 2 over 4. Try one more. All right, so let's go ahead, do our simplifying first. If I simplify the outside, The outside is going to simplify. Now I could divide both these by 6. So if I divide by 6, I'm going to get 3 and 4. So I get 3 over 4. And then my radicals. These can each be divided by 2. This will make 12. That'll make 7. From here, now let's see if we can pull out any perfect squares. Remember, I said, if you see that a number can be divided by a perfect square, the easiest ones to recognize are when they're divisible by 4, divisible by 9. We can take out that perfect square. So right now the 12 has a perfect square inside it. So I want to take out, let's take out the 4. The 4 is going to come out as a 2. So 2 times 3 is 6. On the inside, I'm just left with radical 3. And then I have 4 radical 7 on the bottom. So. And now, since there is a radical in the bottom, I got to get rid of it. So now I'm going to multiply top and bottom by radical 7. So times radical 7 times radical 7. On top, I'm going to get 6 radical 21. On the bottom, radical 7 times radical 7 is just 7. And then 7 times 4 is 28. And now I still have one last step. The numbers on the outside, those could both be reduced by 2. So reduce those by 2, I get 3 radical 21 over 14. All right, so that's it for the warm-up. Next thing you guys got is the lesson. So go ahead and jump into the next video. Make sure you're taking notes while you're doing the lesson, because you're going to need to have something to look back on so when we get back into class. I don't have to explain everything all over again. You know what you're doing.